Hello all, welcome to my channel. This session is the continuation of the last session wherein we have seen how to create a Databricks Community Edition login, and we have also seen how to create clusters. Like you need to just a recap of the last session. We need to click on the compute button and then the create clusters, create workspace, and then we can create different notebooks, right? Today, in this session, we'll see how to navigate through Databricks file systems, like listing the available files, copying the files from one location to the other location. We can also move the files from one location to the other locations, and we'll also see how to delete the files within the Databricks file system, and we'll also see how to delete the folders. There is a slight difference between deleting the files and deleting the folders. We'll also see that, and we further check how to read and write different file formats like CSV, Excel sheets, JSON files, Parquet files, and Delta files. And at the last, we'll also see how to convert different data frames from Pandas to Spark data frames, Sparks to Pandas data frame. And we'll also create some SQL tables and how to convert these SQL tables to Pandas data frames and Spark data frames. So before we start, on how to navigate through DBFS file systems, we need to understand what is DBFS, that is, what is Databricks file systems. Databricks file system is a distributed system wherein the workspace is mounted to a particular storage and it is available on all clusters. Databricks file systems is an abstract of top of scalable object storage that provides optimized Fuse interface. Fuse refers to file systems in user space. And what you can do with DBFS is like it allows you to interact with different object storages like Amazon S3 buckets, and you can also mount different storage directly without giving credentials and without having giving a relative path every time you work with the cloud storage objects. And it also provides a convenient location for storing init scripts, jars, libraries, and configurations for cluster initializations, right? Uh, in this, the clusters, as soon as you run out of time of idle time, like say, for example, if you leave the clusters without working for 2 hours or something, the clusters automatically gets terminated and you have to create the clusters again, right? So in the last session, we have created a test folder in the DBFS file storage and uploaded a CSV file just by dragging and dropping the files from here, right? We have created a test folder and then the CSV file has been uploaded here, right? Like I said earlier, we cannot do anything with the files from this particular thing. You cannot double click, you cannot right click, and you cannot access the contents of these files from this particular user interface. So we need to find a way to navigate through these file systems and to read the files from different locations. So to start using it, we need to have a cluster running. Like I said earlier, right? The cluster has been created. And if you could remember, like we have created these clusters in the last sessions and we tried to restart it, the clusters. But the problem is for the community edition, the clusters once terminated, you cannot restart these clusters. But for a paid subscription, you can restart the clusters so that the files stored within that particular cluster environment, you can use those files regularly. But for the community edition, you have to create a cluster once the cluster has been terminated. So if you could see, my cluster is up and running. So we'll start with the notebook, workspace, users, and the login. And this is my notebook, right? You can see this is a blank thing. And just remember, you need to attach the clusters, active clusters. When this cluster has to be attached. If you attach this cluster and if you write any of for programs here, it will not work and it will give you an error message saying the cluster is not attached. So you need to attach this cluster, and you can also write the markdown functions. This is the file to navigate through Databricks file system. So this is a markdown function, just like you have learned earlier. You just need to use the magic command like %md. And if you write %SQL, this is the standard programming language for this particular notebook is Python. If you write SQL and press enter, it will turn to SQL. And same with Scala and same with R, right? So to start using navigating through clusters, Databricks provides us a nice functionality of using Databricks utility functions. You can write %fs space ls and press Control Enter or Shift Enter to see the files which are stored in your workspace. And this is running. Just a minute. Yeah, you could see there are 4 different locations, right? DBFS file storage is something what we have seen in here. The data, create table, and this is the DBFS file. But if you could see, you see only the file store here, and within that file store, it is having tables and then the test folders, whatever we have created. So, but if you see here, we have 4 locations. This Databricks datasets is something which you can access multiple free datasets which Databricks provides us to work on with these things, right? And this Databricks results are a storage locations wherein all the results, whatever you are saving or whatever you are running, will be saved in this particular location. Say, for example, I want to read the CSV file or I want to check the path of the CSV file which you have created, right? So what I would write is like I'll copy this file store and then I'll check and Control Enter. So within this file store, you'll have these tables, and I'll copy again this and paste it here, run this cell. So this is the test folder, what you could see, and the same thing you can copy and paste it here and run this cell. So this is, we have 2 files, one the Excel file and the other one is the CSV file. You can do the same thing with dbutils functionality as well. dbutils.fs.ls. ls stands for listing of the objects. You can give the same path here, copy this path, entire path, and paste it here. So the output is slightly different in terms of the visualizations, but the exact path, it is already given. You have Excel file here, and you also have a CSV file, right? So to make it more readable, we can use an inbuilt function within Databricks called display. Display and see here. And then run this file. So the output will be exactly similar to the earlier ones. So it is up to you whether you want to use these commands, %fs or ls, or these commands. It's up to you the way you wanted to check the files, right? Now we will see how to copy the files. Say for example, this is the test folder. We have 2 files here. What I wanted is like I want to copy this file and I want to create a new folder called test2, and then I want to paste the test2 folder here, test2 file here, right? So what I would do is I would write dbutils.fs.copy. CP is for copy, and you need to give the source path. So the source path is this one, which we have copied, and we can give the destination path. And then in the destination path, instead of test, I would write as test2 so that this test2 new folder will be created and this CSV file will be copied from this location to this location. So let us run this file. It will give you a Boolean output whether it is true or false. Once it is giving a true, it means your file has been copied from that location. Just refresh this file store, tables, and see. You can see a new folder test2, and within that test2, the file which we have just now copied, right? And we can also move the files from here. Like the copy of this file is available here as well as here, right? So if you want to move the files directly from here, you can move it from this location to this location so that the file here will not be available. So to move a file, the command would be almost similar: dbutils.fs.mv move. So what we would do is, instead of the CSV file, we'll copy the path here. If you want, like, I will paste it here. This is the source file wherein I want the Excel file to be moved to this semi, and I would write test2. Okay, so from this test folder, I want this Excel file to be moved from here, this location to this location. So I'll write shift enter this cell. So it will always give you a Boolean value. So it means the file has been moved from one location to the other location. If you refresh this again, file stores, tables, and test to see. I mean, earlier, if you could remember, we had two files here, one CSV file and the other one is Excel file. But we can see this test2 folder, the Excel file has been moved from test folder to test2 folder, and in this test2 folder we have two files now, right? The same thing we can say, for example, if you want to delete a particular file. So I'll do one thing. I'll delete the CSV file from this particular folder. So to delete a file, the command would be similar: dbutils.fs.rf, and you need to give the path of the file which you want to delete. So I want to delete the CSV file from this test2 folder. I'll write this, and I would do the same thing, shift enter. So again, we'll check the things. So in test2, the CSV file should be deleted. Yes. Now earlier we had two files, one CSV file and one Excel file. Now one file is in Excel format, that is in test2 folder. One file is in CSV file, test folder, right? So what we would do is, like, say for example, if I want to delete this folder, what I have to do, right? So I would do the same thing and write dbutils.fs.rm. Instead of giving the file here, I will just put the path. Okay, so I'm sure it will have an error message. I'll tell you why. So you could see the error: the path is a folder and it is not an empty directory. Say for example, earlier, to delete a file, we have just given the path of this file and it is deleted automatically. But in a case of deleting a folder, if you want to delete a folder, either the folder is to be an empty one, or you have to write a sentence called recurse. But before we do that, I'll try and copy this Excel file to the original test file so that we can use this Excel sheet further. I'll write dbutils.fs.cp. I'll write from this path, test2 path, to the test1 path. So this is the test1 folder. I'll copy this file just to make sure that we have a working file, right? So I'll refresh this again, tables, test, and we have two files here, and test2 we have one file here. So I want to delete the test2 without deleting this file. I mean, the entire folder I want to delete. Say, for example, if you have 10 files, 15 files, 20 files, and you cannot delete each file individually, I want to delete the entire test2 folder suddenly, right? But if you write this command, it will say that this is not an empty folder and it cannot be deleted. So we have to write a word called recurse is equals to true. And when we do that, I'm sure the, the entire folder will be deleted. So if you see here, the entire folder is deleted with a Boolean value as true, which shows the test2 folder has been deleted. So we have just one test folder here, wherein we have different files here, right? So we have seen, just to recap of this particular thing, like we have seen how to list the different files like %fs, and we can also do the same thing with dbutils.fs.ls. I like this. This is more user friendly, and directly you can copy the files from one location to the other, move the files from one location to the other. You can remove the files or delete the files. We can delete the folders as well. Now we'll see how to read and write different file formats. Different file formats can be CSV file, Excel file, JSON file, Parquet, and Delta files. So we'll head back to our notebook. So this is the notebook wherein we'll read different file formats. Like we have learned earlier, we can write %lf and to see the different files available to us, Databricks hyphen data sets, because we have different data sets which are available for free within the Databricks platform. So we'll use those files to read different file formats. So just the command is running. We'll save those different files in different file paths. Like say example, we have JSON file path. We can also have CSV file path. We can have Delta file path. We have different file formats which are easily available in the Databricks. We'll use Parquet file path. So we'll create 4 different variables for these things. Like example, if I see Databricks has a called samples and people. If you check it out, we'll see a JSON file here. So what I do is I'll copy this file path and I paste it in JSON file path. Okay, and we can also search for any CSV files which are available here. We have some R data sets, data. I'm not sure on the exact, I don't remember the exact path. We'll check it out. Data, I think it is not available. We'll see. So we have this file path. I'll see whether if we have any CSV file in it. I think there is a folder called CSV. We'll copy this. I think there should be a folder called ggplot. I think yes, this one. And I guess we'll have a CSV file. So, for example, I'll select this diamonds data set. Okay, and we'll also find some delta data sets. Like we have some flowers data sets in this. So I'll take this file. So we have created 4 variables and we are creating saving the file paths of different file formats. So we also have some Amazon in this. Amazon. I think in this you'll have a, a delta packet formats. Okay, so I'll run this file. So what we are doing is literally we are getting the different file paths of different files like JSON file, CSV file, delta files, and packet files. So if you could see the extensions there. So what we try to do is like we will try and read these files in Spark. So I'll put a comment here, creating a Spark data frame from the above file formats. File formats. So I'll do one thing. I'll create a Spark CSV data frame. So I'll write Spark read dot format. You just have to specify the format whatever it is. So if it is CSV file, then CSV. Then if it is JSON file, it is JSON file, right? So I'll put my things in options. You can write header as true, and you can write options to info the schema as true, and then load. So load, we can give this file path, CSV file path, right? I'll copy this and then save it, right? I'll show this csv.df.show. It should give us a Spark data frame, right? Just it is running. So if you can see the Spark jobs, it means the command is okay and it is creating our data frames at the backend. So this is our Spark data frame. Okay. So in this, you can write header as true like this in this, or else you can write without the quotation marks as capital T and RUE. Uh, Anywhere, you can write the same thing. It will create another Spark data frame. So it's one and the same. Either you can write true as in this way, or you can write true in this way. It's one and the same. And now we have an inbuilt function within Databricks to show these data frames in terms of a clear this thing rows and columns or the pandas structured format. So we can write as when instead of show here, what I can do is like I can write Spark CSV display Spark CSV DF, right? So it's just the same thing, but it is a much better way of visualizing the data frames than this thing. And sometimes, Spark data frames are not clear and we will not be able to, exactly see what it contains. But in this way, you can scroll down different values and you can see different edit things. And one thing, if you have observed, within Databricks, when you have a Spark data frame, you will have this kind of thing wherein you can easily create the visualizations without doing anything. Just if you can click it up, it will give different graphs for the particular data frames. Okay, so you can select, you can go for plot options and you can say, for example, you want the color. You can select X and Y values. You can easily differentiate these things and it will clearly give you the graphs without doing much of the efforts. Without writing any of the codes, you can get the graphs within this. It is like a plotly graph. You get all the customized values here and user integrated and user interface. This is really good. You can expand these things like here. You can make it bigger, you can make it smaller, and you can also download these files if you want, right? And so I'll make it a table again. So this is the way how we read a CSV file. Instead of CSV file, we can also do the same thing, just replace the CSV with JSON files. When I'll write here, instead of CSV, I'll write as JSON. Other format is JSON. So instead of CSV file path, I'll upload JSON file path. And this would be our JSON DF, right? So everything is perfect, and then we run this file. So this is a separate thing. This is a small data set containing only three values, age and name. We can do the same thing for delta and packet as well. Delta and packet are mostly the same formats. Say, for example, if you want to read a packet file, uh, packet, we'll write as packet here instead of JSON. I'll give the packet file path, packet, and this thing, packet. So it's running again. So you can see the data which is written in packet file format. So delta format is similar to the packet file formats. The only difference is like delta formats are the most widely used in data engineering to ingest the raw data and streaming data, for example, and you can perform some transactions which are acid proof, like they are preferably for acid transactions. So delta formats is something a wide topic range, so we'll not discuss, we'll not go in depth in terms of delta file formats, but yes, this is a format wherein you can read different files. Instead of packet, I can write as delta here. I'll rename this as delta, and this is also a delta. Say, for example, if you want to read a delta format by using this packet, it will give you an error message because these two will have some logs. Say, for example, this incompatible format detected. So you need to have a delta format here. Okay, so I'll copy this and I'll load the delta format. Okay, I'll say this. So this is the delta table, which is more or less similar to our regular packet files. The only thing is it performs much better in terms of ACID transactions. Right. Normally, within data science and data engineering concepts, these CSV files are converted into a delta format, and then those files are given to different data scientists or different data analysts based on their requirements. So I'll show you how to convert this CSV file. Say, for example, this is our CSV uh, data frame, Spark data frame. So we'll convert this Spark data frame, Spark CSV data frame, into a packet or a delta format. Say, for example, I'll write this Spark underscore CSV underscore DF. This is my Spark data frame, which is converted from a CSV file. What I can write is like write and mode. For now, I would write it as overwrite. You can also have the mode as an append thing, and then format. In which format you want to save this? Either it can be in Parquet or it can be in Delta. For now, I'll save this in Delta format and then save. I'll give a file location. Say, for example, if you could see our data DBFS has this file locations, and wherein we have this tables folder and then the test folder. So instead of test folder, I'll create another folder here and I'll save the entire thing, right? So what I could do is, so just a minute, I'll copy the path, so that we don't have any typo errors. So, so instead of test here, what I would write as delta CSV. This is just a name. You can write anything like CSV dot delta, whatever it is, CSV underscore delta, whatever it is. So I'll write as CSV delta and then run this. So this is running, and it hopefully it should save the CSV file in the delta format, right? It might take some time, but what it does is like it does the RDD transformations at the backend, and it transforms the CSV file into a Parquet format again, but with ACID transactions compatible. So if you see this thing again, if you refresh this tables, now you have this delta format wherein you'll have different file formats. If the size of the file is really big, then you'll have multiple partitions, and in this you'll have a delta log, which contains the entire metadata of the things of the files entire. You can append, you can overwrite the files, and normally the data comes in batch or data comes in streaming. So most of the streaming data sets are being saved in delta format, and multiple files will be created over a period of time if you continuously append a particular file system. So there are some best practices to save or to work with delta files. So that we'll not consider it for this session, but later on we'll definitely try and give some information on that. So say for example, now we have learned how to read and write the files of different file formats in Spark data frame. Say, for example, if you want to read a pandas data frame, so you can simply write a import pandas as PD. And in this, the only problem is you cannot directly read the pandas data frame from the file location. Say, for example, I want to read this particular CSV file path. Say, for example, this, I'll copy this. If I want to create a pandas data frame, so pandas df as pd dot read csv, so csv, and if I write this path, I think it should give me an error just because the Databricks environment cannot find the directory this way. So what we could actually do is like we can write Spark df, like this is mean just if you want to see, this is a Spark data frame. So this is a Spark data frame. We can convert this into a Pandas data frame. Say for example, Spark CSV underscore df dot to pandas. There is a function called to underscore pandas. So I'll write convert this as pandas df is equals to, and now if I write pandas df dot head, so it can be created. The entire Spark data frame has been converted into a Pandas data frame. So this is the Pandas data frame. So the only thing with Databricks is you cannot directly read this, Pandas from a directory, so that it will not give you a proper data frame. It will give you an error. So what we can do is like you can create a Spark data frame and you can convert that into a Pandas data frame, and you can work on it whatever you want. Right now we'll see how to create a SQL tables. Normally what we do is like in terms of regular Jupyter notebooks, what we do is like we have a Spark data frame, we create a temp view as this thing, just a minute, create or replace temp view, and then we'll write a sample table, whatever it is. So like I'll create sample table so that we can write our queries on this, right? We can write our SQL queries on this. So I'll write a spark.sql. I'm not sure whether it works, but we'll try it, right? Select star from sample table. So, and dot show. So this is our thing, right? What we have done is like we have created a temporary table in terms of SQL table, and we have used this sample table to query our results. And we can also extend our query. We can write where color is equals to E or F, whatever it is, right? think we have done a mistake here. We'll see. Yeah, it should work. So we have selected only the rows wherein we have this F thing. If you remember, like in the last session, we have discussed that in the data tab, whenever we create a cluster, we have a default database called default, right? But it does not contain any tables. So how do we contain, how do we create tables in this, and how do we exactly do our SQL queries? So what I would do is like uh, we'll convert this Spark CSV data frame into a SQL table. Write dot mode. I will write it as overwrite, and then instead of any other file format, what I would do is save as table. And I save it as table, and I give any name, like say for example, I would give a diamonds name on it, because this data set belongs to a diamonds data set, right? This one. So this name can be anything. I'll run this cell, and then if you could see, it does create a SQL table. And if you write percentage SQL, you can directly write our queries, SQL queries, like select star from diamonds, right? So this would be a much better way, at least for me, I like this way of, querying the SQL commands, rather than, converting, creating a temporary table here and then using spark.sql every time and then dot show every time. So this gives us a clear picture of whatever it is, like whatever we want. Say, for example, we can further extend this query where color is equals to G, I would say G or J. Okay. So we can write these queries, and then we can literally create the graph of it. Say, for example, I can write select depth from diamonds where color is J. So, for example, I'll write it this command, and I can easily plot it whatever way it requires. Yeah. So I can. There are different plots. We can have a scatter plot. We can have different. Again, this for scatter plot, we need to have two things. Maybe the histogram. Okay, we can extend it, we can extract it. So this gives us a clear picture on having just a SQL query, and then you can plot the graphs in it. So if you do in this way, you cannot have these kind of graphs within the Databricks, because the options are not available in this, right? So this way you can convert a Spark data frame into a table. And if you want to see whether the table is really saved or not, this is the default database, and the table which we have just created, it is available here. And this table, remember this tables, whatever we are creating, will be available only in this particular cluster. As soon as the cluster gets terminated, the tables will not be available. So it's always a good practice to see, to drop the tables as soon as our work is completed. So at the last of our program, I normally would try as drop table if exists diamonds, right? So this is a much better way of dealing and dealing with the storage and dealing with in uncorrupted things. I mean, if you see now we have deleted the table, and if you would see the table is not available. And whenever you want this table again, you can create it again like this, create it, and then you can run this, right? So this is how we can read and write different file formats in Spark, and then convert it into Pandas, and we can also convert it into SQL tables. What if we want to read this particular file formats, all these file formats directly in a Spark, directly into the SQL table? Say, for example, I have copied this again. So I want to create a, instead of creating a Spark table, Spark data frame, and then converting it into the diamonds thing. Say, I'll see if it exists. It exists. So I'll do one thing. I'll drop this diamonds table, and I would, now it is not available. So what I would do is, instead of creating a Spark data frame from the CSV file and that converting it into a tables thing, I can directly read, directly read this CSV file as a SQL table. What I would do is percentage SQL, and I would write as drop table if exists, and if at all it exists, then it drops, or else it does not do anything. And we can write multiple SQL commands by just having a semicolon here. If we don't write semicolon here, we'll have an error message. So what I would do is, like, I would create a table like you normally do it in SQL, create table. I would write the table name using, this is a keyword again, using, you can use CSV file, CSV, and options. Within the brackets, you can give the path. The path is the Spark CSV file. I think this one, CSV file path. I'm sorry, CSV file path, and I can write it as header is equals to true. So if I run this, it should work. I think we are having an error here. So what we could do is, like, instead of writing the CSV file path, we path, and then we copy and paste this file path. Okay. So this thing, and then it should work now. Yeah. So now we have directly created a table here, a diamonds table. So instead of creating a Spark data frame and then converting it into a table, we can directly read these file paths into a SQL table, and we can write anything, any SQL commands like you have done earlier. So there is another method of creating a SQL table. I'll write the same thing. Instead of diamonds, I would write as diamonds 2. Okay, just to differentiate the above command with this. So I'll create a table again. I would write as diamonds 2 using is a keyword here, using key CSV. Instead of options giving path and even giving as header is equals to true, I can directly give as location, and then copy. Sorry, I can copy the location directly. So I'll copy this location and then paste it here. Right. So this gives us a second table called diamond 2 if you want to check it out. Now we have a second table called diamond 2, and we can have any number of databases, any number of tables within the database. And if you want to see how many databases sorry, it contains, so show databases, like you just do in our regular SQLs, right? You can also query SQL show tables. So we have two tables, one is diamonds and the other one is diamonds 2, and we also created a sample table which is not available now, like, I mean, which is not visible in this, but if you remember that we have created a sample table by using this thing, temporary view or table, right? This thing. So this is also a table which is available for us for this particular cluster mode. We can work it out, right? So we have seen, I mean, say for example, we can also convert these tables into different data frames. Say for example, what I would do is I would write as diamonds 3. This would be a Spark data frame. I can read the table itself, spark.read.table, and I can read any of the above tables and converted that into a Spark data frame. I would write as diamonds and then display diamonds, right? Diamonds underscore 3. So this we have created a Spark, another Spark data frame just by using the available tables here. Okay. So just to recap, in this particular part, what we have done is we have taken different file formats. We have saved those in different variables, and we have created Spark data frames initially using Delta format, using Parquet formats, using CSV file formats that we have displayed using an inbuilt function called display, and then we have written that Spark data frame into a Delta format again. So I've shown you what Delta frame and how it looks. And we've also discussed that we cannot directly read the Pandas data frame from the directory within Databricks. So what we have to do is we have to convert that Spark data frame into a Pandas data frame, and we can work with all Pandas commands after converting the Spark data frame into a Pandas data frame. After that, we have created a temporary table to just see how queries can be done within the Spark, which we can also do in this way. But my preferable method of using Databricks for SQL operations is this way. We can create a separate table by using this command so that we can have SQL queries, and we can easily have these kind of interactive graphs, and we can plot any of the things, and we can have different plot options wherein we see different things. We can adjust the number of bins, we can change the display type, whatever it is. Okay, we can also change the aggregation functions as some average without writing any of the codes here. So this is one of the fastest way of analyzing our data in a quick way, and we can drop the tables, and we can also create SQL tables directly from the CSV path itself. We have shown different commands wherein we can convert different things, right? And we can also convert a specific table into a Spark data frame again. So that's it for this video. So hope you all like it. And in the next session, we'll see how to work with practical interview questions on different databases and how to convert those things in Pandas, SQL, Spark data frame, and all. Thank you. Thank you very much for watching. Thanks.